Hello everyone. In this video, I will be talking about scriptable objects. Scriptable object is a class that lets you create objects that are not attached to any game object in the scene, and they are most useful as data containers. I want to give you some background information about what are data containers and why we need data containers. But if you want to directly see how scriptable objects are created and used in Unity, you can skip ahead. Data containers are extremely helpful in using two good programming principles, which are separation of data in code and separation of concerns. I will explain these two principles using a simple example. So as an example, I have a simple first person shooter game, and in this game I have two guns, for example, an assault gun and a shotgun, and these two classes represent each of these guns. I will have some common parameters like name, damage, rate of fire, etc., and some functions like shoot and reload. So you can imagine in the common approach, what you would do is create different classes which each of these parameters for different types of guns. Like you can create a different class for a sniper or for a revolver, etc. What separation of data and code principle means is that you separate the logic of your code from the data on which the logic is to be applied. So in this example, what will happen is that instead of every gun having its own set of parameters directly inside the code, what you can do is, in a better way, is that create just a single gun class which will have all the common functionalities like shoot, reload, maybe take aim, etc. And the gun class will only have functions. It won't have the data on which it is going to act. So it will be a common class containing just the functionality and the logic, and what it will act upon will be a class called gun data. And gun data class contains all the parameters which define how different guns behave. In this case, gun data is a class and it is filled with different parameters. But in reality, in actual games, what happens is that your data won't be in a form of a class. It can be your whole gun parameters can be defined in an Excel sheet. It can be in a form of XML. It can be in a form of text file. But the basic idea is still the same, that your main gun class just contains the functionality, and your data, suppose you, in this case, after applying the separation of code and logic, what you will have is that a set of data called assault gun data, which will only contain the parameters like damage, rate of fire, name, etc. And you will again have a shotgun data which will contain those parameters, and they can be arranged in any form, in a Excel sheet or a text file, which is very easy to edit. And this data will be then fed into your gun, and this data will determine how a gun actually behaves. There are many benefits of separating data from the code. The first obvious benefit is that if you have not hard coded your data inside the source code, the designer never has to touch the source code. So you can be sure that your source code is never accidentally tampered with. The second is that since data is separated and is in a very compact form like in an Excel sheet or a text file, it is very easy to edit and maintain, and it is very easy to add stuff to that later in development. More benefits are of scaling and searching, with they both conform to the ease of use of editing or maintaining your data. The last benefit is of the modding. So if in your game, if the logic is separated from the data, it is very easy for modders to add the user generated content to your game. In games like Kerbal Space Program or Cities Skylines, the whole game logic is separated from every game entity in the game. So it is very easy for players to create their own content, modify the game parameters, and while the engine remains the same, the new data set creates a completely new experience and increases the longevity of the game. Scriptable objects are one of the ways in which you can store your data. So I have already talked about how you can store data in your Excel sheet or text file, but scriptable objects has the benefit that they are very easy to edit and they exist inside your Unity project. So you can directly edit your data in the default Unity inspector. You don't have to leave the Unity editor application. Now to contain a scriptable object inside Unity, we first need to create a class which will define what are the parameters that we want to save inside our scriptable object. So if you remember the example of the gun that I showed you, so the parameters relating to gun were things like name, damage, and rate of fire. So first we will define a class which will contain those parameters, and with the help of that class we will make actual scriptable object assets, and these will be different data containers for, let's say, different guns. So I will create a data container for assault gun with those parameters. Then I will create a new asset, a new data container for shotgun and for each and every gun in our game. So first we create a class which will hold the data. So let's name it simply gun data. And to create scriptable object, all our classes must derive from the scriptable object class. And since gun data is just a template of what are the type of things that we want in our data container, we also need to use the create asset menu attribute. This is an attribute provided by Unity, and it is a shortcut of creating data container assets inside your project. Now once you have the a class deriving from scriptable object and you have added the create asset menu attribute, now you can create data containers inside your Unity project. And the way you do that is going inside your project folder, right clicking here, and then going into your create sub menu, and for every scriptable object uh, in your project, it will create a new option inside your create sub menu. Now for gun data class, I have an option of creating a new gun data asset. So here is my new gun data asset. I can name it, let's say, assault gun. Now this thing here will contain all the data related to assault gun. I can create a duplicate of it. This I can name is as shotgun, and this will contain data related to the shotgun. Now let's add some parameters to our data containers which will help us differentiate between different guns. So they can be like public string, gun name, public float damage, and public int ammo capacity. Now once we have added those parameters, when we go to our scriptable objects, we can see that now each scriptable object, each of these data containers will have those parameters. And to make them different, in our assault gun data container, we can let's change the parameters, like to name it AK-47, damage 35, and ammo capacity 30. And for our shotgun, let's make it like this. Now each of these data containers now contain different values and they represent different types of guns. Now the next problem is how to use these data containers into a common gun class. And the basic idea is that the gun class should only contain functionalities like shooting or reloading, and it should be able to accept any data that we feed it. So we can put AK-47, the player can change his weapon to a shotgun, and the gun class remains the same. It just differs based on which data you are feeding it at the moment. So let's create a new gun class. And the way to access these data containers, these scriptable objects, is that you create a public variable of the same type as your data container. So currently our scriptable object class is of the type gun data. So inside our gun, we'll create a new public variable of the type gun data, and this will be same as the class that you have created for your data. So if you have another scriptable object which contains player data, so you will have a new public variable here of the type public data. For the gun, we only need the gun data, so we'll create a public gun data variable. Let's simply name it gun data, and this is now able to accept these different scriptable objects. I can create as many copies, as many different data containers for it. I can create a new data container for revolver, give it different parameters like pistol, damage 29, and our gun class is able to accept any of these data values because all of these scriptable objects are of the type gun data. Now just for demonstration, instead of shooting and firing stuff in our public void shoot function, we will just debug information about gun data. So you can see that gun is currently operating with these set of parameters. So we will debug.log. First, our data container has our name, damage, and ammo capacity. So we will debug that information. So gun name is, and the way to access data out, extract data out of your data containers is that you write your variable name gun data in this case, and it is accessible just like a normal class. So gun data dot name gun name plus, this is for the new line, and next we have our damage, so we will debug that as well. And the last line would be to debug our ammo capacity. In the actual game, it surely would do different things. Our shoot function would behave differently, but here we just want to see how our gun data will function equally, and the only thing different would be which data type it is fed upon. So to call this shoot function, we can simply use our input dot get key down our x key. So whenever I press x, the shoot function would be called, and we can see how gun behaves differently based on these different gun datas. Right, now coming inside our game, the way you feed these data into your gun class is by simply dragging and dropping your scriptable object assets, because since these behave exactly like your normal assets, like how you can drag your materials into your inspector or your textures, etc. First, let's add the gun script into our scene. So I will create a new gun object and add our gun script to it. And now this is our public gun data variable, and it can be fed any asset directly through your inspector. Let's go into the play mode. And now since we have not fed any data, the gun data variable would be null, and if we press X to shoot and get the debug message, we'll get the null reference message, right? And now we are free to add any gun data. So let's put our assault gun into our gun class, and let's see what happens in the console. So pressing X now would give us the data which corresponds to our assault gun. So it is now, the gun class is now acting upon the assault gun data. It gives you the name, the damage, the ammo capacity. Now while still in the play mode, we can in the runtime change which data we are feeding into our gun class. So this is similar to the player changing his weapon, or if the player has picked a new weapon, so we can directly pick the suppose a revolver data and assign it to our gun class. Now when I press X, it will start showing me the pistol data, the data related to our pistol data container. In the same way, we can feed it the shotgun data, and it will show me the shotgun data values. Now you see how easy it is to uh, for a single gun class, and we just have to replace it to feed it different data sets, and these data sets are directly accessible right inside the Unity inspector. So any designer can just go to his assault gun scriptable object, change the parameters which correspond to the assault gun. So the designer can come here, go to the revolver and change the appropriate parameters. He never has to touch the gun class. Only the programmer is responsible for the source code, and the designers can very easily and very quickly change and balance these parameters. So this was the basic process of creating a scriptable object, feeding and defining what type of data it is going to contain. And I also showed you how you can extract that data into a template class which can act upon different data sets. There are some other properties of the scriptable object. One of them is that the data inside a scriptable object remains constant through every scene reload. So if you have changed the data in your scene 1 from let's say change a value from 2 to 5, and if you reload the scene, the value 5 will be preserved during the scene load. It is used, so it is, this property is useful in cases when you want to uh, move data between scenes. Another interesting property is that you can assign custom icons or thumbnails to your scriptable objects. So for example, if you want to give a different icon to all of your gun data scriptable objects, you can do that by simply creating a new folder called gizmos, and inside that folder you will have to add a texture and name it same as your scriptable object class, which in this case would be gun data, giving a space and then writing icon. So I will show you by importing a new texture here. The size 128 into 128 works perfectly, and just rename it to our scriptable object class name and icon. Now you see all our gun data scriptable objects have changed their icon. So it is very easy to identify, and it is especially useful if in your project you have different sets of scriptable objects, like a set of gun data, a set of bullet data, player armor data. So this can be useful to differentiate between them.